I want you to remember this. When a factor x minus k, like x minus 2 or something, is raised to an odd power, the graph crosses the x-axis, like there. It crosses at 2 in this situation. And it could be x minus 2 to the third power. But the point is, if it's odd, usually we've been dealing with 1, But it could be 3. Anyway, it's going to go through. If it's x plus 1, like we have here on this graph, and it's raised to the second power right there, then it's going to touch and go away. It's not going to go through. Okay, it's going to touch in one place at -1, and then it's going to turn and go the other way. Okay, I've been calling that KISS, but anyway. Find all zeros of the polynomial function. All right, well, let's see. You can see that it says all, not just the real ones. And you can also see that it only touches the x-axis in 2 places, so the writing's on the wall there. We're going to have a couple that aren't real. But it looks to me like that's a -2, and that looks like a +1, so I'm definitely going to try those. I know that my first number here, 8, is 1, 2, 4, and 8, the factors of 8, and then I have a 1 out here, so there's a 1 on the bottom. So those are my factors, and I said I was going to try -2 and 1, so let's go ahead and do that. Well, we'll start with 1, and our coefficients are 1, and 2, and 4, and -8. All right, and we'll bring that down. We'll say 1 comes down, times 1 is 1, plus 1 is 2, times 1 is 2, plus 2 is 4, times 1 is 4, added to 4 is 8, times 1 is 8, and I get 0, as I had hoped. Okay, and I'm not going to stop there. I'm going to go ahead and go on to -2. I'm going to say -2, and we'll just keep this going with the leftovers. And we'll say 1 comes down. -2 times 1 is -2. I get a 0 when I add it to 2. Times 0 is going to be 0. 4 plus 0 is 4. Times -2 is -8. I get 0. I get 0, and so 0. I guess I didn't need to keep going there. Sorry about that. I didn't need that. This was where I should have stopped right there. This was, I don't count that, do I? Okay, so anyway, now we have x minus 1 for up here, okay, and we have x plus 2 for right there, and then let's see the leftovers. For this, and this, I'm going to get x squared, 1x squared, no x's, plus 4. And as you know, I cannot factor the sum of perfect squares there. So those are going to be irrational. Those are going to be imaginary. And I hope you can, we could do the quadratic again. And if you don't recognize this, I encourage you to use the quadratic. But if you use the quadratic, you will find, first of all, you'll find that b is 0, and that simplifies it quite a bit. But you're going to say that x would be 2i, negative or positive, right? Because if I square 2i, what do I get? If I square it, I get 4i squared, which is -4, right? And -4 definitely goes with +4 to make 0. And then let's see, the other situation is if I have -2i, and I square that, then I would get 4i squared, which you'll not be surprised is the same thing. When I square it, it takes care of the negative sign. But then the I squared always puts it back. So that's the only way I'm going to get a negative out of x squared is if I get an I in there. That's the only way. So it's an imaginary number. And what else is x equal to? Well, x is equal to -2 from right there. and x is equal to positive 2 as well. So x is equal to these four things. Those are all the zeros, not just the real ones, but the imaginary ones too. That's what they asked me to find. Yep. Okay, so there's the real one, there's another real one, and two that you can't see because they're pretend.